Hi everyone. Today I'll be talking about the latest open source reasoning model DeepSeek, which was released by a Chinese hedge fund recently and whose benchmarks are almost on par with O1, the reasoning model of OpenAI. So DeepSeek has two models basically. One is DeepSeek R10 and then there is DeepSeek R1. So with R10, they followed the approach of only RL, basically reinforcement learning, and with DeepSeek R1, they also used supervised fine tuning with RL. So let's first what's the difference between RL and supervised fine tuning with RL? With reinforcement learning, it's like training the model to iteratively improve itself by giving it a reward function and defining a policy for the model. And when you add supervised fine tuning also to it, it's like giving it examples heads on to identify how to output for a given input. So they first tried with RL only, but they hit a bottleneck that the outputs were not readable to the user, and there was a multilingual mismatch in the output generation by the model. So they also added an SFT layer to it. So what is reasoning basically? So reasoning right now, what we are seeing is this chain of thought. So chain of thought, if you see this here, if you see this is a question that if a is greater than 1, then the sum of the real solutions of this equation is equals to. So what model does is that it first thinks about the answer before responding it directly. So the current models that we use today are like the chat GPT, the Claude. You give a query and then you get a response directly, so there is no thinking time there. But here the model takes time to think first, iterate on its approach for the solution, and then answers the final output. So in their paper, the DeepSeek team has mentioned this as a aha moment, like a eureka moment, where they saw that model was trying to re-evaluate its steps and then finally generate the output. So so this is an interesting thing with chain of thought. Basically, with chain of thought, we have reasoning behind the final response generator, and then we get the final response. If I show you the outputs, so yeah, here I ran a distilled DeepSeek model, 14 billion parameters square. Here I asked a question, then it thinks about it, and then and finally it stops the thinking, and then it generates the final output like this. Like think block ends here, and then the final output is there. I also asked it another question, that how many hours, the famous number of hours question in the word strawberry. It failed at this, but again, the if you read this thinking approach, it's quite interesting that how the model thinks, and how it changes its approach, and how it reevaluates itself on every step. So this is something interesting to read the think format, although it's not fast enough. The inference times are like near to 2 to 5 minutes, so it's not good for like go to tasks. But yeah, to for tasks which require a lot of period, where you can just give a model some task, and at the end of the day you have to get the results outputs, and you just evaluate the answers, and you just deploy them, like whatever I'm talking in the sense of code. So this is the chain of thought, right? So after chain of thought, let's talk about reinforcement learning. So reinforcement learning, there are two basic components in reinforcement learning. One is reward, and then the other one is policy. So for reward, we have reward functions, and policy is basically a decision making of an agent in an environment to get the maximum reward. Basically, the objective of reinforcement learning is to maximize reward, and the policy which we define is the decisions that an agent here, which is an LLM, would take to maximize that reward. So if you see this basic chart, here's the policy, which is denoted by pi theta, and then there is reward on the y-axis, and the policy and reward grows with time in a RL training loop. So that's RL. So in R1, they basically used a algorithm known as GRPO, Group Relative Policy Optimization. where they used basically GRPO was used to define the policy, and then for reward system they had a rule based reward system where they used two rewards. One was the accuracy reward, which was like they generated a lot of coding outputs from their model, and then they just tested the code. Basically they generated a lot of lead code solutions with the help of their base model with this RL training, and then they also check the format of the outputs. Format is basically for the structured output, the thing you saw here between the think blocks. This is what they trained the model to do. That's why it outputs everything between these think blocks here also. And then we have accuracy reward to test the accuracy of the model, and not to test, basically just to maximize that it's accurate most of the time. What they saw here was that with time, the model grows, the output of the model grows. Like if you're RL training v3 on this GRPO policy, then the model learns it by itself to generate lengthier outputs with time, because it knows that it has to think properly to generate the proper reasoning for any kind of output. Then there is this very important equation in the paper. It's the objective of the complete policy which is used for this training. So let's little break it down a bit here. So this is basically this part QPQ. It's just list of sample questions, like the question queries which we give to the LLM, and then this part right here is the output tokens for those questions. Basically, when we have some sample questions, we would have the output tokens for each of that question to, and based on the policy which we have to use to maximize the reward. Then here we are just this is basically policy of the newer model and the policy of the older model. Here we are basically trying to compare that if two models and their policies. So pi theta here is the policy. AI used here is the advantage term. So what advantage term defines is that output token is the best on the basis of probability of all possible output tokens, and gives more preference to model with higher probab. So if a new model, if a new model gives a higher preference to a token, then this particular portion of the equation would suggest the model to give more preference to that token. And if the model gives low preference, if the new model gives low preference to a token, then optimize the objective to give to not choose that token, basically. So the whole thing is that we have to choose the token which new model prefers more. But again, then when we move to the next part, clip part, and this clipping part is basically done to avoid overconfidence. Now when you are allowing the newer model to like choose the next token and to give more preference to the token selected by the newer model, there are many chances that it might go on into overconfidence, and you don't want that. Basically, you don't want models to be overconfident. That's why we use this clipping technique, where we just avoid overconfidence by the model by defining a ratio limit of 1 minus epsilon to 1 plus epsilon. And then there is the scale divergence term which we deduct from this objective, which is basically to measure the two distributions basically. So what happens is that when a model tries to maximize the reward, it might do something which it might get, like it might find a hack to by which it can just like get the maximum reward. For example, if I say, like I heard this, like for example, if we talk about um, a child, like if you give a chocolate to a child and you tell it that okay, you will get a chocolate if you study. Now for study, if we say, like if we define what is studying for a child, so it would be like sitting with the books open. Now what a child can do, he could just sit for hours just to show that he's studying, and actually he's not studying, and in that way he's getting the chocolate. So he found a hack around for the reward system. to maximize the reward, and in that way we have to avoid that. So for that we use the scale divergence term. And apart from this, have if you want to go deeper into like how the loss functions are calculated and how is reward actually implemented here, I would definitely suggest you watch Umar Jamal's complete explanation, deep dive into it. It's on YouTube. You surely check it out. It's a gem of a video. And then let's move on to the distillation. So there are three main parts in this paper. One is the chain of thought, and the other one is the distillation, and the third one is the reinforcement learning. So we talked about chain of thought, we talked about reinforcement learning. Now let's talk about distillation a bit. So what is distillation? Now distillation is most of the time I would say confused with fine tuning. It's different than fine tuning. Basically, in distillation, we have a teacher model, which is the larger model, and we have a student model. For DeepSeek, they used their V3 model, which was a 670 billion parameters model, and then they used a student model, which was a Llama 8B, 70B, or Quen 7, 14, or 32B. They just distilled all of them, and then teacher model is not a reasoning model actually. Teacher model is a reasoning model. So yeah, here I wrote it wrong. So it's not V3, it's basically, it would be R1. So teacher model is R1 671B, and then student model are the smaller models. Then teacher model is an already reasoning model through which we generate some data. And what we try to do, like teacher model generates the chain of thought data. Like you will give it a query, it will generate a chain of thought, and it will generate a response. Then we try to produce similar chain of thought from a student model. And how do we do that? We try to mimic the logits. Now, what are logits? Logits are basically unnormalized scores of tokens before converting to probabilities. What is that? Basically, these are raw scores which are given to tokens generated by a model just before they are converted to probabilities. Now, probabilities are used in LLMs to predict the next token, which has to come after the, like for example, if we take this sentence, teacher model is a reasoning model already. So if we give LLM input teacher model, then it will generate probabilities for next output tokens, where is or any other token would might get the best probability, and it would be there. Then these three would go in, then will come, then these four will go in, then the reasoning will come. So in this way logits are being calculated. So what we try to do is that we take a bigger model, we generate data from the teacher model, and then we try to teach the student model how to mimic the logits of the teacher model. In that way, what we achieve is that if we achieve reasoning for smaller models. So basically what distilled models can do, like right now what I was showing you guys before, this is a reasoning model. This is a distilled model. Basically this is a distilled Quen 14B. So if you see, R1 also responds the same 671 billion parameter model, and this is a 14 billion parameter model. This also responds in the same way. Now quality might differ, but still the structure is same. The accuracy would be almost near. The only difference would be the number of parameters. So distillation is a very good technique to mimic the behavior of a larger model into a smaller model. Now, supervised fine tuning, we already talked about it, that feed in labeled data. Basically, it's supervised learning type thing only. Now, with supervised fine tuning, what you can do is you can create your own custom data with a query, chain of thought, and a response. And then you can feed it to a smaller model, basically, or to a already distilled model to fine tune it for some specific use case, for a niche use case, or for a custom use case. Now, I would like to talk about what you can do with this right now. Like I have a few things which I am working on. So what I am working on is I'm preparing a programming questions data set. So first I looked up on the internet, but then I realized that with the distilled Quen 14B or 7B, we can actually produce our own data set, and it would be a high quality data set. So what I am doing is what I have done is I've generated a few phrase questions of programming. Let's say, let me show you guys. If we go here, yeah. So here, if we go coding questions, wait a second. Yeah, so I had these examples. I had these coding questions. So it's just a phrase: implement secure input validation for a file system, address common vulnerabilities, and follow security best practices. This is a security question, this is a medium difficulty, then this is a database question, then this is a algorithms questions. Now I just designed these phrases with the help of simple random choice in Python, and I gave it a like bunch of list of like where to choose from and what to join and what to not. And then after this I like passed it to GPT or a different model. I passed it to O1, not O1. I passed it to 4O Mini basically, and 4O Mini gave me this. So I converted those phrases into more user-like questions. Like I'm trying to implement a recursive function to reverse the string, like what we ask GPT, what type of questions we ask GPT. I converted to that. Then after this, I went on to a distilled model and I generated, this was my input which I generated before. Then the R1 distilled model, which was I was using Quen14b, which generated the chain of thought for that, and then it also generated the solution. Now, so this is my data set. Now this is a smaller data set. This is not this is a dummy one, but actual data set would be a much larger one. And then you can just fine tune the data set, fine tune the model, basically another model on this data to give more better answers on this topic, or on programming, basically general programming. So this is the schema you can use. Like this is the which I use basically. Query would be the question, COT would be the the text between the think blocks, and then response with the response will be the final solution. Then what I am doing is I am generating examples more than 2000 in number, because I think that would be good enough to train a smaller model like a Llama 1B or 3B, because that's what I'm aiming for right now. I'm just experimenting. And then after that, eval the fine-tuned model and compare with the original model before fine-tuning, which would be your eval, and which should tell you that like even like if it's worth it or not, because I don't know right now that if it's good enough to do this, because I think Llama 1B 3B are already like would have some coding knowledge already. But let's see, this only will come out after the eval. Now this is not distillation, this is just supervised fine tuning. With distillation, student model will give outputs similar to the parent model in chain of thought, so that's different. In distillation, after distillation, like the output structure for both models would be same. If you use a parent model with a chain of thought answering type structure, output structure, then you will get the similar output structure in the student model as well. Here, if you use the chain of thought data set in fine tuning, you won't get the chain of thought responses from the student or the fine tuned model. You will get similar QA responses, but with the help of the chain of thought for a question, they would be much more fine tuned to answer queries, like complex queries. Now, one more addition that you could do is that add a RAG with continuous updating of documents of a tech stack. Now this is just an idea which I'm working on right now, that with this model, just add a RAG, basically a live RAG, which is getting updated from the documentations of, like, say a particular tech stack like Next.js, CUDA, or Ethereum, and you just link that RAG with the this model, which is just fine-tuned on COT programming questions. So you have this programming knowledge and you just link it with the updated documentation of a particular tech stack. Now you get a like what you get is a very good coding agent in a particular field. So it's not a journalized model, it's a smaller model but a expert model. So this is what you get from this is what you can try out, or there are like n number of things that you could try out out there. Now how you can run the model locally. So distilled models are available on Hugging Face, Olama, and you can also use through VLM. I am using Olama right now. I'm running 14B model on my 3050 Ti. which is 4 GB RAM, so it's quite compute intensive. I've also run on a 48 GB VRAM Ada RTX 6000. On that, I was able to run, I guess, 32 billion parameters of distilled model Quen, which ran like I think at a good speed of 12 to 15 tokens per second, which is good enough. So what with Olama, what you can do is Olama serve. First set up the Olama on your device. It also runs on Windows. It's WSL installed here, but you can also try it on Windows. Olama serve, and it's giving errors because my Olama is already running on this port. This is the port where it will run, 11434, and after this you can just do Olama run DeepSeek model. These commands you can easily find out on Olama's docs, and then you just run and it will just load the model. It will run on your GPU. So just switch on the fans if you can, because it uses a lot of GPU. So that's one thing. And after that, I think it's good enough if we see one overview, like what DeepSeek R1 did with their reinforcement learning approach. That was that they took the base model V3, which was just a simple LLM model, question answering LLM, and then they fine tuned it on reasoning examples. They generated the reasoning examples. Everybody is saying that with the help of OpenAI with their O1. So they gave it a query, generated the chain of thought, and then generated the final output. Then they used the GRPO for reinforcement learning. One advantage of using GRPO was to basically, not only GRPO, if we talk about reinforcement learning, is that iteratively, after every iteration loop, the model learns to get the maximized reward, and it learns how to produce the output which gives the maximum reward. And they defined reward functions and the policy very smartly so that the model can generate longer outputs over a period of time with relative to reward. And in that, what happened is that you get these long generation of text while the model is just thinking and re-evaluating its outputs, which we saw here also. That here in the example which they used in their paper, they like, let's re-evaluate this step by step to identify if the correct sum can be. Like, this is something which a human would do after, like, if a human is not getting the answer correct, it would re-evaluate it. That's why I think models like these, which takes a lot of inference time and a lot of inference time compute, these models are very useful for tasks like which you don't want just now. Like, if I want to ask something just now, I would go to Claude, or I would go to ChatGPT, or even Perplexity. But if I'm like not in any urgency to get any output right now, I can just define the tasks properly, and I can give a list of tasks to this kind of a model, and just tell it to implement all the tasks, and it will take its time, think through it, and generate the final output. And then at the end of the day, I can just go and check what are the outputs. So if the outputs are good enough or not. Like here, Quen 14b is running, so if I can just ask it what is RL, so it will start thinking about it, and it will generate its whole thought here. And it's really fun to read these thoughts of the LLMs. Now it's running very super slow on my laptop, but like, yeah, see here, like it's here you can also see that if I ask a very basic question like what is RL, it might not also think. Like, it knows that RL is a type of machine learning where an agent learns to make decisions in an environment with the help of policy and whatnot. So like, this is also a good thing that their model has learned. So there are a lot of distilled models. You can check them out on Hugging Face also. Like, from Hugging Face you can directly download the model and can run. You can test these models, or also you can just serve the models on some other cloud platform and just use them. Like, experiment with these models. These are like super cool. Read about Distillation, and do check out Umar Jamil's video for detailed explanation of what's happening under the hood in this maths. I gave a little bit overview, and I'll also share the link of uh, this canvas. If anybody is interested, they can do, and do share if you want to discuss more about DeepSeek or want to deep dive into the project or something. Yeah, thanks.